Hey all. Today, or in this video, what I want to do is take the Bayes bad parts / good parts example that we did in class today and put it into Excel. And so we started off in class today looking at a probability tree for our two supplier example. We get our parts from two suppliers. Supplier A, we get 65% of our parts from them, so the probability that any given part chosen at random came from supplier A is going to be 0.65. The probability that any randomly selected part that we just pull out of our parts drawer, that it came from supplier 2 is going to be 0.35 or 35%. So we have supplier 1, 65% of our parts come from them, supplier 2, 35% parts. But one of the problems we're having is that there's a part that is bad. And we're trying to figure out where these bad parts are coming from. And if we just looked only at our first piece, we'd say, hey, 65% of our parts come from supplier 1, so the probability that this part came from supplier 1 is 0.65. However, we updated this with a new condition, and the condition hinges on the fact that supplier 1 and supplier 2 don't supply equal proportions of good parts and bad parts. What we can see here from this first conditional probability statement is that the probability of it being a good part, given that it comes from supplier 1, is 0.98, and the probability of it being a bad part, given that it comes from supplier 1, is 0.02. How we'd translate this into common language would be to say that 98% of parts from supplier 1 are good, and 2% of parts from supplier 1 are bad. If we translate that or take it one step farther and look at supplier 2, represented here by A2, we'd see that the probability of receiving a good part from supplier A2 is going to be 0.95, where the probability of the part being bad, given that it's from supplier A2 or supplier 2, is 0.5, meaning that 5% of the parts supplied to us by supplier 2 are bad, whereas 95% are good. So what I want you to see here is that although we get more of our parts from supplier 1, supplier 1 provides a higher ratio of good to bad parts. 98% of their parts are good, as opposed to supplier 2, where only 95% of their parts are good. So as we work our way along these trees, we can get here the first conditional probability. The conditional probability tells us that the probability of a part from our drawer being both from supplier A and being a good part, it's going to be equal to the probability that it's from supplier A multiplied by that conditional probability that it's good given that it's from supplier 1. So we multiply 0.65 times 0.98, and we get 0.6370. This joint probability here tells us that 63.7% of the parts in our stock are going to be good parts that came from supplier 1, our first supplier. Since supplier 1, A1 here, only 2% of their parts are bad, we could figure out the proportion of parts that are in our parts warehouse that are bad parts from supplier 1 by taking 0.65 multiplied by 0.02. So in the language of probability, it would be that the joint probability of a part being both from supplier 1 and bad is equal to the probability that it came from supplier 1 in the first place, our 0.65 probability, multiplied by the probability of it being bad given that it's from supplier 1, right? They only provide 2% of their parts are bad, so if we get 65% of our parts from them and 2% of their parts are bad, 1.3% of our parts are going to be bad and from supplier 1. We can take that working through these next two cases. The piece that's important here is if we're looking at bad parts, trying to figure out if we have a bad part, where did it come from? Well, 1.3% of our parts are bad, supplied by supplier 1, and 1.75% of our parts are bad, provided by supplier 2. To figure out the total fraction of our parts that are bad, we can just add these two together. So when we got to the end of class, we had done this in writing, And I promised you we'd get a video showing how we would apply this to Excel. And that's what I wanted to start with. Well, finish with, or at least do. And how I like to set these up is refreshing us with our big question. What's the probability that a randomly selected bad part came from supplier 1? So in this case, if I'm writing this down as an equation, or the probability that I want to get, what I'm going to ask myself is, what's the probability that it came from supplier 1 given that it's bad? And that's going to be equal to, borrowing from this first convoluted equation here, it's going to be equal to the probability that a part came from supplier 1 multiplied by the probability that it's bad given that it's from supplier 1. So in other words, the proportion of our parts that come from supplier 1 multiplied by the proportion of the parts from supplier 1 that are bad. And then in our denominator here, we are just looking for divided by the probability that they're bad. Well, that's a whole lot less than this going on here. But what we can see here is that the probability that it came from supplier 1 multiplied by the probability that it's bad given that it came from supplier 1 is this piece here, right? 65% times 0.2, 1.3% are bad. And the second half of this expression, the probability that it came from supplier 2 multiplied by the probability that it's bad given that it came from supplier 2, is this line down here. The probability that it came from supplier 2, 35%, multiplied by the probability or the proportion of supplier 2's parts that are bad, which is 5%, meaning, basically adding up all the bad parts. So this denominator here is just the probability that it's bad, because it can be either from A or from group 1 or from group 2. So this is sort of a simplified final equation. But I find it quite easy to put in a table. So I start here with the probability that it came from supplier 1, or probability of A1 is probably what I should be calling this, is going to be 0.65, whereas the probability that it came from supplier 2 is 0.35. Then on top of that, I have these conditional probabilities, right? Which is what proportion of the parts from supplier 1 are bad and the parts from supplier 2 are bad. So the probability of it being bad, given that it came from supplier 1, is 0.02, and from supplier 2 it's 0.05. So then I multiply straight across this line, just like I did here. I'm going to take this arm because I'm interested in bad parts, and I'm going to take this arm because I'm interested in bad parts. I don't actually need the rest of it for this piece, but I'm going to multiply straight across. So 0.013 probability that a part in my stock is bad and from supplier 1, and 0.0175 probability that a part is in my stock, that a part chosen randomly from my stock is bad and from supplier 2. And if I add those two together, I get essentially the proportion of bad parts in my stock. 3% are bad. So then if I want to get this revised probability, the probability that it came from supplier 1 given that it's bad, I'd just think, okay, 1.3% of my parts are bad and from supplier 1, divided by the 3% that are bad in total. So once I know that a part is bad, the probability that it came from supplier 1 is 42.6%. And the probability that it came from supplier 2 is 0.574, or 57.4%. And so what this updating has done is it's taken the probability that a given part in our warehouse comes from supplier 1 from from 0.65 down to 0.426, because they have a better track record of making good parts. If we know that the part is bad, we realize that it's more likely to have come from supplier 2. So if I want to wrap this up into one more mathematical expression, I will copy this and paste it. What I can say then is that I can substitute the probability of A1, or the probability of it coming from supplier 1, as 0.65 multiplied by the conditional probability that it's bad, given that it's from A. They provide 2% bad parts, and then dividing that in total by the whole probability of a part selected at random from my stock being bad, which is 0.0305. I will try that again. 0.0305. Otherwise known as 0.426. There we go, we implemented it in Excel. Happy calculating.